Welcome. Today we explore Robert Boyle, the arch-naturalist whose pivotal shift from alchemy to empirical science helped usher in modern chemistry. Join us as we examine his foundational discoveries in gases, indicators, and elements that reshaped our understanding of the physical world. Born in 1627 to Ireland's wealthiest peer, Robert Boyle was shaped by immense privilege. From an elite education at Eton to a European grand tour studying Galileo's physics, his aristocratic early life provided the perfect foundation for a remarkable journey in science. Moving from nominal privilege to deep spiritual conviction, Boyle transformed from an aristocratic wanderer into a devout virtuoso. Dedicated to seeking truth and serving humanity, his uncompromising faith guided his life, even leading him to decline the presidency of the Royal Society over the taking of oaths. Through the three books framework, Scripture, Conscience, and Nature, Boyle united faith with science. Rejecting pure Aristotelian logic, he viewed empirical experimentation as a religious duty, serving as a priest of nature to decode the hidden structure of God's creation. In The Skeptical Chymist, Boyle broke from ancient dogmas, replacing Aristotelian elements and Paracelsian principles with corpuscular philosophy. By viewing matter as mechanical particles, he established three foundational pillars: quantifying gases, systematizing qualitative chemical indicators, and isolating elemental substances. In Pillar 1, we explore quantifying the invisible. Through groundbreaking experiments in pneumatics, Boyle investigated the nature of vacuums and proved the elastic spring of the air, turning the study of invisible gases into a precise, measurable science. Using Robert Hooke's redesigned air pump, the Machina Boyleana, Boyle engineered a controlled vacuum to test air's fundamental properties. Through pioneering experiments in acoustics, combustion, and respiration, he proved that sound, fire, and life itself depend entirely on the presence of air. Boyle's famous law emerged from a team effort. Townley and Power first identified the inverse link between pressure and volume, Hooke engineered the precise testing apparatus, and Boyle conducted rigorous experiments, validating the data and publishing the findings as Mr. Townley's hypothesis. Through the landmark J-tube experiment, Boyle measured the physical spring of air. By adding mercury to compress trapped air, he demonstrated that pressure and volume are inversely proportional, defining the mathematical law that the product of pressure and volume remains constant. In Pillar 2, we turn to systematizing qualitative chemistry. Investigating the striking fluorescence of lignum nephriticum, Boyle unraveled its dual-color optical mystery. In 1664, he discovered that this shift depended on pH. Acids erased the blue glow while alkalis restored it, pioneering the fundamental concept of chemical indicators. By transforming color changes from alchemical novelties into reproducible tests, Boyle established color as a systematic diagnostic tool. Using indicators like syrup of violets and lignum nephriticum, chemists could now reliably classify substances as acidic or alkaline, introducing rigorous standardized testing to chemical analysis. In Pillar 3, we explore elemental isolation. While pursuing the legendary philosopher's stone, Boyle's experimental methods yielded the glowing icy noctiluca, white phosphorus, demonstrating how alchemical curiosity ultimately led to the systematic isolation of true chemical elements. In 1669, Hennig Brandt accidentally discovered a glowing substance from boiled urine, keeping his recipe secret. When shown this cold fire in London in 1677, a fascinated Robert Boyle resolved to reverse engineer the isolation process on his own, unlocking the secret of elemental light. To reverse engineer the icy noctiluca, Boyle mastered a four-step thermodynamic process. By concentrating organic phosphates, adding silica under intense heat, and driving carbon reduction, he distilled and captured pure, solid white phosphorus underwater. Where Hennig Brandt pursued secretive alchemy and yielded an impure paste, Robert Boyle applied rigorous method and open publication. By isolating pure white phosphorus and enabling the first friction match, Boyle demonstrated the triumph of systematic chemistry over mysticism. Behind Boyle's work stood the Pall Mall Partnership, a lifelong intellectual alliance with Catherine, Lady Ranelagh. Uniting experimental theory with brilliant networking, they edited each other's manuscripts, shared medical remedies, and actively promoted one another's scientific ideas to advance early modern natural philosophy. In the Laboratoria's Temple, we see the shared home of Robert and Catherine, a vibrant salon for leading thinkers and the site of groundbreaking experiments that separated chemistry from alchemy. Here they worked side by side until the end, dying just 8 days apart in December 1691. Robert Boyle's legacy rests on twin pillars, pioneering modern chemistry through empirical rigor and Boyle's law, while championing faith by funding global Bible translations and endowing the Boyle Lectures. His life proves that rigorous science and profound devotion can thrive in perfect, mutually reinforcing harmony. Embodying the motto, "Take nobody's word for it," Robert Boyle transformed natural philosophy into modern science. By insisting that theories strictly match observation, publishing all experimental outcomes, and championing rigorous protocols, he established the transparent, empirical foundation that defines scientific discovery today.